This video is to show you how to do problem number 1 on energy conservation with a rotation word problem. Do problem number 1. Now, this actually doesn't have problem number 1 doesn't have anything to do with energy conservation. It's just how to find the moment of inertia. Now, in our lab, if you watch the lab videos, it told you what that was. Basically, for things spinning, the shape of the item and the mass combine together to act like mass does when you're going in a straight line. Okay? So if you have a big I, then the object doesn't want to spin. It's harder to get it to spin or harder to get it to stop spinning. Just like if you're going in a straight line, a big mass, a big M, makes it harder to stop. So it's moment of inertia. It has to do with inertia. So the bigger the I, then the harder it is to change its spinning. Either make it spin faster or slower. So we're just going to calculate it. I will always give you these formulas. So we have a few I formulas. We have that for a solid sphere, a ball, it's 2/5 mr squared. For a solid disk, it's 1/2 mr squared. For a hoop, it's mr squared. And a mass in a string is mr squared. So we have a solid sphere with a radius of 0.25 meters. You don't get much easier than this. I just take this formula, I equals 2/5 mr squared, and I just plug it in. So if I need a 5 there. 2/5 times my mass was 10, times my radius was 0.5, and that turns out to be 0.25. And I'm not going to be picky on the units, but we can look. It's mass, which is kilograms, times meter squared. So that's how you do problem 1 on energy conservation with rotation.